Hey guys, it's Trey back again with another video. And in today's video, we will be taking a deep dive into the BMP file format. We did this before with a couple of other image formats on this channel. We did the PNG format and also the SVG format. So if you guys haven't checked those out, go ahead and go take a look, and then you can compare them to the BMP file format. All right. So basically, the BMP format is a rasterized image. So basically, what that means is we can take the image data and represent it as an array of pixels. So we've done this before with the PNG format. So it shouldn't be too much different there. And it's mainly used on Windows. So that's pretty much, I think they are actually the ones who created it. I think so. But yeah, so that's neither here nor there. Let's go ahead and talk about the structure. So the file structure here, as you can see, it has a bunch of different sections in the file. So basically, we only want to make a simple BMP file. We're going to do like how we did with the other two file formats. We're going to make the simplest possible. We're going to write it from scratch. Actually going to write a generator that can generate a BMP file. So as you can see, we're just going to start, and we're looking at the non-optional sections here. So we have a file header, which is not optional. We have a DIB header, which is not optional. We also have a pixel array, which is not optional. Everything else is optional, and we're not going to write it into our generator, all right? So let's take a look at the file header. The file header is 14 bytes, and it starts off with an ASCII value, basically saying what type of file it is. So we'll be using this BM header because we're on Windows right now, so that's what we'll be using because we'll generate the file for that. Not really going to worry about the rest of these. These are for different operating systems. And then here we have the size of the file, which we will calculate in our generator by, we'll know the size of the file by the dimensions of the file, and we'll add up the headers and everything, and we can do that ourselves. These next 4 bytes, they are reserved, and we're just going to put a value of 0 for them. I honestly don't know what they're used for, but we'll just set them to 0. Then the next 4 bytes is the starting address of where the pixel data is. All right, so we're gonna write all of this out in our generator. So that's what makes up the file's header. The next part we have here is the DIB header. All right, so this is basically just the information about the image. All right, and we're going to be using this one here, the bitmapinfo header. All right, so if we scroll down, we see here, this is it. The reason I chose the bitmapinfo header is because in this page, which I will link in the description, it's a Wikipedia page. It's actually specified here, you know. So that's the reason I picked it, so you can see exactly what I'm doing when I'm writing the generator. But let's go through these really quick. We have the size of the header, which is going to be 40 bytes. It's always going to be 40 bytes for this header. All right. And then we'll have the width of the image, the height of the image, and this is in pixels. These are signed integers. And then we'll have the color plane, which is always going to be 1. And then we go down and we talk about the bits per pixel. So this is important. And the reason this is important because the way the bytes have to be structured in the pixel data, it will change depending on what we set here. So we're going to use a 32 for our image, and this will kind of make it less complicated, but I'll explain that later once we get down to the pixel information. The next thing is the compression methods being used. We're going to use 0 because we're not compressing this data. And here it says the image size. We're going to also set this to 0 because we will be using this this BIRGB, so that won't really matter. And then we set the resolution for the horizontal resolution, and then the vertical resolution here. And then we have the color palette. We're going to be using 0, which is going to default to the full length of the color palette, which is 32 bits for what we used up here. All right. And then the next and the last thing is the important colors used. So we're just going to put a 0, which basically says every color is important. Doesn't really matter. All right, so that's pretty much the DIB header. And here we go. So this is what I was talking about earlier, the BIRGB, and that means we're not compressing this image. It's just going to be raw data for the image. All right, if I scroll down here, we're not doing the color table, so I'm going to skip over this because we're just using all of the available colors in the range. So no need to even create a color table. And now for pixels. So the pixels are stored in an array. That's why what I told you earlier about the rasterized image. So we are storing all of our pixel data in an array. All right. So a pixel is basically just one area on the screen. So like if you look at your screen and you see that pixel count where you hear like full HD is 1080p and all this different things, it's basically like the screen is made up of individual pixels. So each pixel has a color. All right. And that's what makes up the image, that the full image that's on your screen. So when we set the length and the width, that's what we're doing, setting how many pixels we want. All right. And when we do that, we need to set a value for each pixel, which basically tells it what color to display at that pixel. So when we do that, we're having an array of pixels, and this array can be kind of broken down into like a matrix. So we'll have, if we do an 8x8 image, each row will have 8 pixels on it, and it'll be 8 rows of pixels. All right. So that's what that is. And we need to set a value for each one of those 64 pixels, okay? And the way it's broken down is each row will need to be a multiple of 4. So the length of each row will need to be a multiple of 4. So when we're using 32 bits per pixel, which is what we're doing, it's already going to evenly round out for us. That's why I said we're going to use 32, because we don't have to do any padding or anything like that. So this basically is going through how to do all the padding and all of that stuff. We don't need to worry about that because of the way we are structuring it. We're using 32 bits. So that's pretty much it. After that, that's it. We don't need anything. I know with the PNG, we needed to have like an end chunk. We don't need anything to signify the end of the file. We'll just stop the file there, and that's it. All right. So really, we only need 3 parts. We need the file header. Let me scroll back up so I can show it to you. So we're going to need the file header here. We're going to need the DIB header and also our pixel array. And that will be the simplest BMP that we can make. The BMP we're going to make today is going to be a 128 by 128 image, and it's 32 bits per pixel. And that's pretty much all we need to know. And then we'll set it up, and we'll just create like what we tried to create in the PNG video. We'll create a square in the middle of the image. So it'll be like a blue square or something with like a white background. So that's it for this video. In the next video, we will actually write the generator. Thanks for watching. Like, subscribe to the channel and all that jazz. And I will see you guys in the next video.